And it's my pleasure to introduce Wesley. I met Wesley about, I don't know, 3 years ago maybe. A mutual friend, Kurt Pedersen, was the CIO at the time of Oregon State, and he ran the open source lab. And he got Wesley to come to Portland we had a group of many CIOs from the region, and we were interested in Google API, cloud development. We were all exploring research computing from different directions, and we were interested, maybe Google's a player, and Wesley was great in helping us understand what was a possibility. I was fascinated to find out a little bit of his history too. He really had a lot to do with the creation of Yahoo Mail, which my wife still uses, so I fully appreciate that. But he's a California guy. Cal Berkeley, lives in San Francisco, is a development advocate or developer advocate for Google, which is really, this is a perfect venue to come out here and advocate for what's possible. How might Google get involved in, I don't know, whatever kind of project we might think up. We think up a lot of them here. So it's my pleasure to introduce to you for our keynote, to kick off RTD, Wesley Chun.
Thanks, Greg. Appreciate it. Thanks to Greg for inviting me here. I'm very happy to be in front of all you guys. Wait, before we get started, I have to take a picture because my boss, I have to justify to my boss that, hey, I actually did something for the travel expenses I'm about to file. So y'all look happy out there, okay? Pretend the speech was great and it was done.
Oh, and Wesley, tell them that the best thing was when I asked you if you do this, you said, well, I know where Missouri is, I know where Raleigh is, and there is a connection here.
All right, it's an interesting connection. So I don't know if you guys know, but if you drive up the 63 heading toward Jeff City, you go a little bit east of there's a little place called Bonnet's Mill. Anybody heard of it? You're from around the area. So there's a historical bed and breakfast there called the Dauphine, and some friends of mine own it. And it turns out that we're all fans of the Alan Parsons Project, which is a musical band from the 1980s, 70s, and 80s. I don't know if you guys know them. But if you know Pink Floyd and Dark Side of the Moon, Alan was the engineer for that album, and he was nominated for the Grammy. So, and he also worked for Paul McCartney and Wings and the Hollies and stuff like that. So we're all big fans, and we gather every year in the middle of Missouri, in the middle of the country. And it was great because it's actually midway for everybody, right? It's not like people have to fly further than other people. Oh, some of the Europeans and Mexicans have to fly a little further, but anyway, so that's my connection. So I used to come out here every year, fly in Kansas City, drive across to Jeff City. There was no non-stops from the Bay Area to get to St. Louis, so that's why I always live in Kansas City. But that's the reason why I'm like, maybe I can plan a trip to visit them at the same time as doing this talk. So anyway, I'm very happy to be here. I am happy to represent my company as well. But a lot of you guys have come up to me and said you're great Google fans, and I think that's wonderful. I think that the fact that you guys are interested is great because there's not a lot. We don't make a lot of appearances in this part of the country. So I'm happy to kind of be that guy that takes the first step. But I also want you to keep in mind that at Google you have to consider us troublemakers. Okay, that because what we do is we go into industries and we disrupt things, and that's sort of like a theme. It's not in my talk, but it is a current theme as well. And that is, don't be satisfied with the status quo. Keep an open mind. Don't be so rigid in your ways of thinking. And there are unlimited possibilities, right? There's one major web browser that everybody uses. Can't have that. Let's throw something in there and mix it up a little bit. There's only one smartphone operating system. Can't have that. Got to get in there, mix things up. Throw things around. There's only one business office productivity suite out there. Can't have that. Got to mix it up. Throw something in there. There's one big giant retail online vendor. Can't have that. got to mix things up. So we're considered troublemakers, but hopefully by stirring the pot a little bit, we get people thinking more, we get people innovating more, and I think that's way more important, right? I mean, you guys probably know us pretty well. We're not really good at charging money for things, anything, right? There are some things that we do charge money for, but we're trying to support business as well too. So just think of us as troublemakers, all right? So with that, I'd like to get started. I was having a little trouble setting up here. I don't know if I didn't get a chance to sit with you all to have lunch today, but I'm normally used to giving presentations on my own computer because I have it configured to do what I want it to do. I'm kind of a lazy person. I'm not really good with PowerPoint and things like that. So as a programmer, I developed all of my slides in plain text. Can you guys see it? This is my slide presentation. And so I was going to, if things didn't work out, I was going to present that to you. Let me see if I can grab a thing in my bag here because my laser pointer is not really printing. Okay, let me get the other laser pointer because this one gets absorbed by monitors, so you can't even see it. I can see it on the wall here, but anyway, so I do all my presentations in plain text, and people are like, wait a minute, you're a keynote speaker? That's unprofessional. All right. What they don't realize is that as a software engineer, why should I go and make a presentation? I'm used to writing things in plain text, so I prefer it that way. All right. So I want to. So instead of doing that, instead of like working, on the airplane, trying to edit something that wasn't going to work, I decided to take the programmer step and actually write a piece of software that will actually take my plain text presentation, and it's a Python script, obviously, and convert that into PowerPoint. So I was going to give you a demonstration of what that looks like. Okay, now it's working. All right, so my friend Bud here is going to help lead me through this, but typically I would create this plain text presentation that you see here. Oh, this one's good, it's over too. So click on Start, and then pull up this guy. And this is normally what would happen. You would actually see PowerPoint come up. It would actually make the slide deck for you. All right? Because I don't have time to fiddle with images or things on the plane because the plane's shaking around. I like to write my entire presentation in plain text and have a tool generated from me. Because why should I have to do it, right? I'm not a professional speaker. I mean, I am a speaker, but I want to write my presentations in plain text. So he's going to stop this, and then because for some reason on Windows 7 the images don't come up, you can see they're kind of blurry. So he's going to bring up the pre-made one that I have already, and then we'll go from there. But anyway, that's how I was going to start the show. I just couldn't do the Windows 7 version, so we'll just do the normal one. Okay. Anyway, welcome. Thank you. I'm happy to give you my opinions and my impressions of what I've seen over the last couple of years as trends in computing and where I think we're headed. Okay, so a little background about me. I am a software developer. If you do know Yahoo Mail, I was one of the original 9 engineers that helped build that 15 years ago. There were only about 9 of us, and it only took us half a year. There was no such thing as web frameworks. PHP didn't exist yet. I think there was Cold Fusion. Anybody remember that? Yeah. And that was it. All right. And our system was built in Python, and we had to make up our own web framework before that term even existed. So that's what I did. Ironport. The clients you see below there, that is a device that filters email for spam and viruses. So it seems like I have some email in my career. There's about 1 million lines of Python code running each of those boxes, and at its peak, we can process about 500,000 email messages per hour. So that was pretty good. So Rocket Mail was the first version of Yahoo Mail before we got acquired by Yahoo. At Slide, I made Facebook games, or actually the back-end analysis of Facebook games, running MapReduce job. Nearby Now was a local product search company, which unfortunately was a victim of the 2008-2009 economic downturn. But the most interesting thing that I've ever done with Python is work on software to help doctors analyze patients with spinal fractures. So talk to me later about osteoporosis. All right, I know a little too much about it. I'm also a writer, so as you know, I've written a couple of books, but mostly out of need. When I learned Python way back in the 90s, okay, there were only 2 books on the market, and they were not made for developers, and so I just couldn't wait any longer, so that's where that comes from. But I'm also a teacher. I've been teaching for over 30 years, and I'm really happy to go to conferences and give talks. I do private corporate training as well. I'm also a local part-time faculty member at Foothill College, which is a community college in Silicon Valley. So enough about me. This talk is actually about you guys. Hopefully you're some sort of professional in industry, education, or government. I want to try and open your minds and have you think about possibilities, and I'm just sharing my thoughts and experiences with you about that topic. And the topic falls under 6 particular themes, and that is ubiquitous computing, same thing goes for learning, programming, cloud computing, big data, smart applications, and then data science and analytics. So those, I think, are all part of the future. How it all shakes out is TBD, but I'm just going to briefly go into each of these areas so that you can start thinking about them. So ubiquitous computing just means that you have a computing device that's with you all the time. You're online all the time, 24/7, whether it be your desktop, your laptop, a server, your tablet, or your mobile phone. Okay, so those are the usual form factors that we're familiar with. And you are with your devices, whether you're online or offline, driving. There are some holes driving to St. Louis from here that you don't have much cell access. I'm sure you guys are aware of that. But you still got your device. You still have the email that was already downloaded to your phone, so you're always interacting with your device. Hopefully it's in the car, it's just a GPS while you're driving, and nothing more than that. So there's also social networking, where you can talk to your friends and family. You're basically online 24/7, and some psychologists think that the world is maybe a little too connected. We're not disconnecting, and young kids these days, if you take the internet away from them for more than X number of hours, they start getting twitchy. All right, so I think, if you guys go on vacation, try to disconnect as much as possible, because otherwise, your spouse may do something bad to your devices, like she's done with some of mine. Good thing she's not here right now. It's not being recorded, is it? Oh, hello, honey. I love you. All right, so those devices that I showed you are things that you expect. What about things that are not as expected? And that kind of leads to the Internet of Things, which is the Internet of everything, right? Your TVs, if you have a modern day flat screen TV, got a Wi-Fi antenna in it, you can actually talk to online. You can go pull down Netflix videos, you can watch YouTube videos. It asks you for your Wi-Fi, your login point, your access point, and your password, right? So your video games, okay? Your cars are pretty soon going to have internet connectivity if they don't already. There are already some cars where you can just drop in your iPhone or your Android phone and boom, you're connected. It uses your cell phone's connection. This is just a picture of Android Auto, which is a system and a standard that we've signed a couple of automakers on, where you plug in your Android phone and instantly your entire nav system switches to this interface. It's not your phone's interface. It's a different interface, but it just uses your phone as kind of like a server that you've attached, and it runs like a full version of Google Maps or whatever it is that you want to run. It plays the music that's on your phone, so you're going to have internet in the car. Your in-home small appliances are connected to the network. So Nest is a company that we acquired a little while ago, but if you've never heard of them, they make these thermostats and smoke detectors and carbon monoxide detectors that are also online, and you can actually check how warm it is at home. So if it's if it's too hot during the day, before you get home, an hour before you get home, turn on the air conditioner using your smartphone. Okay, these things obviously are connected to the net, so you're going to see more and more home devices that will have internet access. Okay. Yes, even doorbells. Okay, so I don't know if you guys have heard of these two companies. The first pair of images are from a company called Skybell, and the second one is Doorbot. But basically, these are internet-enabled doorbells. You got somebody's visiting your house. They press on a doorbell. There's a camera on them. It'll it'll basically bring up a movie. It'll ring your phone. You pull up and see who it is. You talk to them, hey, who are you, or whatever. If they're the FedEx guy, let them in the gate, but don't let them in the front door so they can drop off your package. But if it's your mother-in-law, just ignore it. Or if it's like your kids, you can let them in the house. All right? It's also obviously internet enabled, right? Adorable. Can you believe that? And furthermore, now that I've kind of expanded your imagination a little bit, these products actually do exist. They're still a little rough around the edges based on some of the reviews I've read on Amazon, but you get the trend, right? You get the idea of kind of what's coming. More and more things in the house will be connected. Even things that you don't expect. Okay? So you have a fridge, but you don't really know it's online. Why would your fridge be online? Right? Can you think of a good reason? All right. Now, imagine, do you guys know what RFID is? Right? The little things, right? So imagine you're walking through Schmucks or whatever supermarket you're at, and all of a sudden you get buzzed on your phone as you walk down the aisle. Well, your phone got a message from your fridge that you walk past the milk aisle, and your milk is down to about a quarter left in your half-gallon jug. All right? So you just got notified that you should pick up some milk just because you were at the right place, and your phone had an app that talked to the fridge that knew how much milk you had because there's a sensor on the milk carton with RFID, and then it talked to the fridge, and then the fridge talked to you. All right? That's coming. I mean, it sounds kind of bizarre, but you can kind of sense it. But to me, it's still kind of weird if the fridge has internet connectivity. But I don't know. Maybe there's other things. I don't know. I don't think it's worthwhile to put it on your bathtub. Unless you're afraid that maybe your grandparents may have slipped and fallen in the tub or something. So that might be an application as well too. But just start using your imaginations, because you too could create a fantastically successful startup if you just get the right thing online. Okay? All right. There's also wearables, of course. That's another thing that allows you to be online anywhere, everywhere at the same time. I actually have one, so if you want to take a look at this Android Wear device, which is a Samsung Gear Live, afterwards feel free to come chat with me. It's kind of like that one, but it's a little prettier. It's got color and all that kind of stuff. But what are the main idea for these things? The main idea for these things is that these devices is, for most of the devices that we have to adopt our lives to the technology. We have to learn how to use the phone. We have to learn how to use a TiVo. We have to learn this and learn that. These devices are trying to do something different. They're trying to adapt technology to your lives. How do you make technology not distracting? How do you kind of simplify so that the interactions you have with the technology are very short, that it doesn't interrupt your lunch with your friend, that doesn't interrupt playtime with your kids? But you do want to know when your parents are arriving at the airport so you can leave on time, right? You want these short notifications. And so that's what these things are all about. So Android Wear is a library that's built for Android devices that, based on the notifications you get on your phone, it'll actually send those to whatever wearable device that you may have. And of course, these are just the two that we have now, but there could be plenty more, right? There could be buttons or trousers. There's a weird Kickstarter project. Someone's invented a drum kit for blue jeans. Okay, so you can start hitting the jeans and it starts making drum sounds and different sounds. And if you use both legs, you can have a full drum set on your legs. Okay, so that's a real project, and they have a prototype. I haven't seen it yet, but I have a friend who has a friend whose boyfriend works there. So I know they're doing something, right? So it's like who knows? Anything can go. So that's why you need to let your imagination run wild. Because if your imagination picks up on something that will end up becoming successful, you too will reap those rewards. But did you have the vision to think about something interesting enough that would be mass marketed and all that kind of stuff? All right? So again, the wearable stuff is more of adapting the technology to our lives, because we don't want to always get interrupted. Isn't it crazy? How many times do you guys pull the phone out of your pocket every day? Right? For me, it used to be 50 or 60. But with the watch, I see something, I brush it off, and then I'm done. I never had to touch my phone, so it's actually made the battery in my phone last longer because I haven't had to pull it out. And even you can respond to a text message with these things. You can pull up navigation if you need to go somewhere. So there's a lot of things that you can do that don't require taking away from your precious time. Okay, so time is valuable, and if you spend too much on tech, then you get yelled at by your spouse, and it's not worth it. Okay. All right, so that's that. So really, it shouldn't be a distraction. There should be very short interactions, and a computer and a tablet, those things are tools for work. but a wearable is a tool for life. It's something that you have on you, it's part of you, but it doesn't really take that many cycles from your psyche. All right? So now that we have these devices everywhere, anywhere, we're always connected, what is another trend? Anytime, anywhere learning. All right? Of course, this comes from anytime, anywhere computing because you got some device with you. Right? There's an endless number of how-to videos that you can find on YouTube, and even education is undergoing some sort of renaissance. Right? There's all these new things. There's flipped classrooms now. I'm pretty sure you guys are familiar with those, where your kids watch the videos at home, and then they come to school and do homework because they have their teachers and the TAs helping them. So they do their own study, and when they come into the classroom, they do the real work. That's almost like taking a test to kind of prove whether you learned something or not, right? I mean, we've got big companies like Khan Academy and Udacity. I mean, these companies kind of sprung up overnight, and all of a sudden they're so big, they get hundreds of millions of views, right? But anyway, so those are just some examples, right? There's also edX and Coursera and all those. So, and a lot of schools are offering online courses as well. So this is a thing that all universities are going to have to grapple with, regardless of what institution you're at. Everybody's at a different level. Some universities are already offering, lectures that are available online, and other schools are completely all online, right? So you have everything. You guys have to just experiment with whatever campus you work at. Just kind of experiment and see what it looks like, see how it works. There's an entire new field called learning analytics that helps determine, how useful is it to do online learning? Like, what are the challenges? What are things that can't be overcome, what have been overcome, and what are challenges that remain? For example, it's great that you can learn things online, you can watch lectures online, but you still really need to get together with a group of people. So my old manager referred to this as cohort learning, where you get together in a study group, where you're all watching the videos, you're all taking notes, you're all doing homework together. So you're all sort of doing community learning. So that's kind of a trend. The other trend that's related to this, I think, is programming. So I'm not going to obviously show you any code today, but there will be coding everywhere. And everybody in society needs to learn some sort of coding. This sort of comes back to Python, where the creator of Python, way back in 1990, when he conceived of the language, he really felt strongly that programming languages should be taught to kids at the same time they learn how to read and write. Because, not necessarily that everyone's going to be an engineer, but everyone's got to do some sort of programming every day anyway, right? You got to be able to cook something in the oven. You got to, set your thermostat. You got to set your DVR to record your favorite shows. So he thinks that everybody should have some sort of concept of programming. Because, why do you think there were so many blinking 12s on VCRs, right? People were just too lazy to figure out how do I set the clock so the damn thing doesn't blink anymore, okay? So everyone should do some coding. And guess what? In some countries they do. In Estonia, they start teaching programming to their first graders. In Vietnam, they start at second grade. Okay, we're kind of slow. We're lucky that we have some STEM programs now, but usually the STEM programs don't start until you're in 4th, 5th, or 6th grades. But I think everybody needs to learn coding, so I'm on his bandwagon. And I think there's other efforts to kind of prove that. Okay, and one is Code.org. I don't know if you guys have heard about this, but Code.org is an organization that is motivating kids around the country, around the world to code. And they've got all of these famous celebrities, Bill Gates and Mark Zuckerberg, and even like Chris Bosh, who's an NBA basketball player on the Miami Heat. They got them all to kind of give a little snippet in the video to encourage kids to code. And there's an annual week of code where all kids should do an hour of code and pick up something. So there's efforts. There's also Code for America. I don't know if you guys have heard of this, but it's a nonprofit where if you're a software engineer and you want to contribute to the betterment of government and society, then that's an effort to help leverage your skills and help build apps for the government. All right, whether it be federal or state or whatnot. Okay, so there is an effort to get more and more people to code. So that's why I think coding is part of the future. Again, if you really doubt this, all of the online MOOC systems, the online learning systems that I talked about, Khan Academy, Udacity, Coursera, all of these, guess what? Generally, they're first classes. It's usually something on programming, whether it's HTML or Scratch or Python or something. Those are usually the first courses that they offer. All right. Again, to further indicate well, to further the 2 points of there's going to be learning everywhere, and there's also going to be programming everywhere. Okay? So you can start anywhere. For younger kids, Python may be a little too much. You should probably consider something more graphical and friendly, user-friendly, like Scratch, Tinker, Blockly, any of those block-type languages, or Alice. If your kids know Scratch, and they can learn App Inventor. So if you guys don't know what App Inventor is, that was a joint project between MIT and Google, where the kids can use their Scratch skills and actually build Android apps with them. So yes, teaching your kids Scratch is cool. They can do all these little animated things, but once they start writing mobile apps and they can see the power of what they know from Scratch, it's really motivating. Okay, and then Lego Mindstorms, of course, and Raspberry Pi. Those are all fun. Python and Ruby, of course, are next steps up. Some schools teach JavaScript, which is good because if you're doing anything web-related, JavaScript is always going to be there. Of course, HTML5 would be modern standard, and then CSS3. And one thing I want to give a plug to Google Apps Script. I think it's one of our most, it's like a top secret product that we have that nobody knows about, but I think it's a great product, and I think people should start playing with it. The reason is because it's JavaScript, for one thing, so it's the de facto language of the web, so everybody should learn it. But what's really cool about AppScript is that instead of just running within a browser, it runs in the cloud, which is another theme that's coming up soon, all right? And the best thing about this stuff running on cloud is, some of you may have heard of Node.js, which is also JavaScript running on a server. But AppScript is running on Google servers, and it actually gives you access to Google Apps data as well as Google services. So just by writing a little bit of JavaScript, you can really get a lot done. And I'll show you a quick demo of that, just because I think that if you're learning programming and you're learning, Python and/or JavaScript, you should know about it because it can really, really make your life easier, especially if your institution is a Google Apps user. Okay? And then Java and Minecraft, all the teenagers are kind of hooked on that, but it is quote educational, but you shouldn't be playing it 20 hours a day like some kids are. All right, and your choices should be based on the skill level of the kids as well as how old they are. Okay. All right. So an interesting sort of note about some of these tools that you do teach kids how to program with. Some are easier than others. Some are very special purpose. For adults, for us who are working professionals, in order to get our work done, we're probably using something like Java, C, C++, Python, Ruby, or PHP. And for kids, they're probably learning programming on using Scratch or Alice or BASIC or even Python. And so Python's interesting because it's actually in both lists, which is sort of what the creator wanted, right? So that's interesting. So now I want to say something more about App Inventor. The reason why it's interesting, I told you, you're using Scratch blocks. I don't know if you can see a little image right in the middle there. But you're basically putting together jigsaw puzzle pieces to program. And that's why it's better for little kids, because they can pictorially see things. So when they invented this project, they really thought it was going to be for kids, right? But it's when App Inventor came out, it was specifically made to write Android apps with, and guess what? The entire team was blown away when they discovered that only half the downloads were from kids. All the other ones were adults looking for changing their careers. And they did not plan on that at all. So that was quite an interesting surprise because, hey, if you can write a mobile app and make money on it, not having to learn computer science or anything like that, I can just do it with a kid's kiddie jigsaw puzzle language. That's a great thing. So that's, some schools do actually have App Inventor in their courses to really help them learn how to build mobile apps. All right, so that's very, very interesting. But adults were not part of the original equation. So Python, of course, is in there because it's easy to learn, it's simple and robust. I told you that the creator of Python really, really wanted kids to be taught how to code. And it is one of our official languages. And it's a great tool because it doesn't require you to have a CS degree in order to use it. So if you haven't touched it yet, give it a shot. Okay. What else is there? So here's Google Apps Script. All right, I'm just going to show you 4 lines. Okay, so I lied when I said I wasn't going to show you code. It's just 4 lines. All right, so bear with me. These 4 lines of JavaScript code running on a Google server will touch 3 different Google products in a sort of useful way. So think about a Google spreadsheet. I'm going to put an address in. All right, there it is down at the bottom. Happens to be the address of our New York office. All right, but here are the 4 lines of code. The first line of code says bar sheet. That basically makes that AppScript app connect to the Google spreadsheet. that has the address in it. Second line, get me the address in cell A2. Third line, call Google Maps, create a new map, and put a pin on that address. Line 4, call Gmail and send that map to your friend. Okay? In 4 lines of code, you touch 3 different Google products. Nothing else, nothing that you have to worry about. It's done, and you have a sort of useful app. So that's just the tip of the iceberg of what you can do with it. The possibilities are also endless there. So just something to keep in mind. And people are discovering it, but very, very slowly. So I wanted to sort of just give you guys a clue on that. So now that we're talking about running things on servers, we have to go back to looking at the web. We all know the web has been around for a while now, 20 years, I guess, 94, 95. Is it old? Is it out of date? You know, what else can be done with the web? Okay. Well, let's remind ourselves how the web works. Okay. You've got clients, which is you and your computers, talking to some servers that run forever. You make a request, like a search request or a YouTube request, and some server responds back to your request. That's basically how it works. All right. The thing is, though, the web has caused a shift in where the software lives. Previously, all software lived on your computers because you had to download, install it, and all that stuff. But with the web, you only have a browser, so it's really sort of like a framework for all the other software that you don't have installed on your computer, right? Software really lives elsewhere, so this is the beginning of the part of the talk about cloud computing, all right? Everything is in the cloud. This is the future, it's actually here now, even mobile, and I'll kind of like address that in a moment, okay? So, unfortunately or fortunately, all of our lives are online now. Our bank accounts, our travel plans, all right, everything we do revolves around something being online, even your home loan or whatever, right? You've got your Facebook and you've got your Twitter app. Do you really think that all of your Facebook information or all of the Twitter information is actually living on your phone? Because I know some people go, well, a mobile app is installed, you know. The thing is, what can those things do without being connected? Right? If they're not online, they're not really useful, right? So everything is in the cloud, right? So you have to kind of like accept that, all right? So think again, but think differently, all right? Think about what the cloud is for. In fact, there's web-only computers now. So we have these devices called Chromebooks. The only thing they have on them are a browser. Now you could think, oh, okay, I can't really do anything with those. Well, are you sure about that? Because with a web browser, I can go access everything that I need to access online. I can even go get my Facebook and Twitter. I don't need to use my phone. I can't create documents or spreadsheets with it. Well, that's what Google Apps is for, and now Office 365. All right, I can't log into my server. There's SSH in a tab. Okay, so you don't really need to have an installed computer anymore. And guess what? Can you download a virus on this thing? It's very hard to. I can't say it's impossible because it's always possible somehow, right? But if you're not clicking on any .exe files, you're not clicking on weird stuff, you can't do that. There's no Outlook address book to harvest or whatever, right? There's nothing that is that risky. And the other thing is that we're so paranoid. Our company is so paranoid about security and making this thing secure that we actually pay bounties to security researchers that can find cracks in our stuff. So it's always secure. It always self-updates in the background. I apologize to you administrators where Chrome is updating and taking up network traffic when it shouldn't be. But if you have a Google Apps domain, you can actually control when those downloads happen. But for a consumer computer, it just updates whenever because we always want to be sure that you have the latest one. All right? So there's web-only computers that can actually be used. My parents have one. They don't need to have anything else. They do what they need to do, check their mutual funds, check their retirement accounts, all that kind of their life insurance or whatever. Perfectly fine. They can get their prescription medicine fulfilled, refilled, and all that kind of stuff. So web-only computers, imagine that you can actually live on just the web. So kind of a quick word about cloud computing because the reason why the term cloud computing can mean too many things. And so I have this slide to sort of help people categorize things. When we talk about the cloud in general, we're always talking about the software as a service layer, which is the SaaS level you see at the top. That's any app that you have to log in to use. At the very bottom layer is what IT administrators think is the cloud. Oh, I'm going to go get an Amazon instance or something like that. Okay? So there's a bunch of players there, Amazon, Google, Microsoft, Rackspace. We all make things where you can go and rent a computer or rent a big disk so that you don't have to buy it on your own. And it's great for startups because they don't have to use that capital expenditure. All right? Somehow we have to bridge those two worlds because both of them count as cloud computing. And that's what the middle layer is for. At the top layer, we have apps that you don't control. At the infrastructure level, you have to be a sysadmin and take care of everything. So if you were a software developer and you did the infrastructure, not only do you have to worry about your app, but you also have to worry about your complete stack. LAMP stack, you have to get a Linux box, you have to get Apache, you have to get MySQL, you have to use some language that starts with P. I'll let you guys decide which one you want to use. All right? There's a lot of work there, and it's not making it easy for developers to come up with apps quickly enough. All right? So that's where the middle layer comes from. That's platform as a service. Well, I can't see, I guess this thing absorbs it too. So this must be really high-tech monitor there. But the platform as a service layer allows you, if you learn coding like everybody else should, right? If everyone learns coding when they're kids, they'll have some general knowledge of coding. And if that's all you know, that's good enough. Because those platforms, whether it's App Engine or Azure from Microsoft or Heroku, you just write the app, you upload it to Google, Microsoft, Rackspace, or Salesforce, and we run the code for you. You don't have to do any sysadmin. And the best part is when things go out of date, you don't have to throw away all your old computers or donate them because you never spent any money to buy them. But you also didn't have to administer them either. It's up to companies like Google and Microsoft and Salesforce to refresh their machines so that you keep getting the best service. So you don't do any of that capital work. It really is a time saver. You think of the app, and that's it. You don't think of sysadmin. You don't spend the money on it. Obviously it costs those companies and us money. It costs us to run that system, but you got to think of it as a utility service. You're paying for your phone, you're paying for cable TV, you're paying for water. Computing is like a utility too. You never really need to spend that much on your own machines, all right? So, and if you know Python, you can write apps that run on App Engine, and Azure supports Python, and Movie Heroku does as well too, all right? So just by knowing a little coding, you can actually create a SaaS app or any kind of app that people can use, all right? So that's the great thing about platform as a service. I think it's the most powerful because it handles all of the grunt work from the infrastructure level, but you're also not forced to use an app. If you don't like Hotmail or YouTube or Gmail or any of those, write your own, right? The platform as a service system should be powerful enough to let you make one for yourself. Scratch that itch. Scratch your own itch. Don't wait for a vendor to do it. If you have a problem, like with Gmail, you can file a bug with us, but we have hundreds of engineers, but is your bug the highest priority? It'd be better if you could fix it yourself, right? So if you write your own, then you don't have to worry about that problem where you're relying on a vendor. So this is breaking the vendor lock-in story. Although not that Google charges much money for our services, but other companies like to lock you in, and you're paying subscriber basically, right? How do you do that? You write your own apps. How? You've got the code, right? So we're going back to this. You're always learning, you're always online, but you should have some coding skills. Okay, so there's a lot of repeat themes that we have in this talk here. All right. So like I said before, Python runs on all of these things. And the cool thing is, one of the best features specifically about App Engine is that your app will run on the same servers in the same data centers as what runs YouTube, what runs Gmail. You're actually sharing that. So obviously we can handle hundreds of millions of users, but so can your app without you having to do too much work for it. And can you imagine if you were at a startup company, you had to build all that to make it happen, to make it so that if there are 100 million users hit your app, that it won't die, and you set your servers on fire. All right, we spent so much time and effort to make that app to support that we want to make sure that you don't have that same mountain that you have to climb. Solve a higher level problem. Don't worry about the lower level stuff. Okay. So the cloud is no need to buy machines, no need to manage equipment, no one wants to maintain all that old stuff. Just write apps. All right, and using any of those cloud systems, your app is available around the world. It's almost armchair production. You can just sit back, relax, write your app code, and then you're kind of done. It's almost that easy. All right, I can't lie to you and say it is, but it's not that bad. Now that leads to another thing. So we talked about online computing all the time. We talked about cloud computing and how everything's living in the cloud. But guess what else also lives in the cloud? Big data. Why is that? Because think of every single Facebook status update plus every single tweet that comes up every single day. Okay, and you wonder, like, why do relational databases why are they not able to support that? Because it's an overwhelming amount of data. It's just too much. All right. So just to give you a hint, I'm gonna, borrow from some of these articles that I read that were quite astounding to make you think about how much data there actually is in the world now. All right. So Long and Siemens basically said, well, big data is a result of the internet and computers and devices. The bad news about in the education space is that as soon as the problem with lectures and reading a book, there's nothing, there's no background, there's no proof that you were there's no breadcrumbs. In hallway conversations, they just disappear as soon as you're done, right? There's no trace of anything. Every single tweet or Facebook status update leaves some sort of digital footprint. So online learning, digital student records, and all those things, they have rich data trails and activity streams that you can actually learn from. Okay? These data trails give you insight on what's happening. Maybe you can, improve the way you deliver the course. Maybe you can improve the content in your course. All right, there's a link to the article there, but they're basically saying without this kind of audit trail, we can't really know unless you give a survey to people. Giving surveys, not that fun, right? And taking surveys, probably not that fun either, right? Marcia Connor says that in 2012, 2.5 quintillion bytes of data was created, which means 90% of all the world's data was just created in the last 2 years. Okay, and you can just look at the numbers yourself. It's kind of staggering. I can't even internalize that, right? And that's happening every single year. In fact, those numbers are growing every day. So we have an overwhelming amount of data. And then Tim O'Reilly says, well, guess what? The reason why we're able to do this now is because it's storing the information became so cheap that we just do it by default. We don't even think about, should I keep it or should I throw it away? Because that thought process is too expensive. It's cheaper just to let it go to disk, right? And this quote at the bottom here I think is really critical. Companies that have massive amounts of data without massive amounts of clue are going to be displaced by startups that have less data but more clue. Right? You've got to analyze the data. You've got to analyze, how well the student's learning. What are the effects? Can it be improved somehow? Same thing goes for companies. Companies, if they don't look at their numbers, they're not going to know whether they're successful or not, or can be successful. Older quotes from Tim O'Reilly: "Data is the next Intel inside, and we're entering a new world in which data may be more important than actual software." Right? Of course, that's only sort of true because you have to have software to analyze the data, right? And that leads to something else. Big data has to be processed. You can't have just relational databases. That's why NoSQL was invented. It just cannot relational databases cannot handle the amount of data that's being produced every day. And so that's why these systems are made, MapReduce, and do all those things. Big data needs analyzing. In fact, data science is offered as a major at many universities now. And data scientist is actually a job title. You can actually have a career looking into data and doing analytics on that data. Okay? So, of course, you can do all kinds of analysis, but you really want to put something behind it. You want to have some brains, right? Because if they're just dumbass, they're not going to tell you anything. You have to be able to get information out of data. Okay? Google has a tool called BigQuery, and there's other companies that have built software on top of BigQuery to help you analyze things. Why is this tool useful? It's another tool that you've never heard of. I'm only going to tell you about Google tools that you've never heard of. Okay? You can analyze terabytes of data in just seconds, not hours, not days, not weeks. If you give it 5 terabytes of data and you give it a SQL select call, the answer will come back in roughly between 5 and 30 seconds. It's very, very fast. Okay? And it's to help you analyze all of that data, because without analyzing it, you can't pull information out of that data, and it's not useful to you. Okay? So you have to have smart apps. So there are a lot of companies out there that have machine learning algorithms. Google Prediction happens to be one of ours, another product you haven't heard of before. But this helps apps be more intelligent because you can look at a massive amount of data. So here's an example. You give the Google Prediction API this text that you see on the left-hand side there. All right. You ask the Google Prediction API, what is this? And it outputs French, which makes sense because you know what it is, right? But how did this happen? Is this magic? Oh, it's not really magic, because what happens is, in the background, you've uploaded a bunch of data already with the correct metadata to flag to the system what it is. So there's some English text, there's some Spanish text. So given all that data that you uploaded, the prediction API will use any number of machine learning algorithms to kind of figure out, what is this new data, right? Just like what I showed you. So this is one example. Another example that a coworker wrote was, he uploaded all the real estate prices around his neighborhood. He wanted to find out if he had a house this size, how much it would cost, right? Other people use this tool for medical advice. So like if a doctor analyzes you have these symptoms, these symptoms, over 100,000 people, what is likely to be the malaria, the malady that you have, right? So there's lots of different use cases for it. So here are some of them. You could find out, are they Republican or Democrat, or do these people like your product or do they not like your product? So you can use it for all kinds of different things. All right, even spam detection and things like that too. So that's another product you've heard of. So here's another product from Amazon called Mechanical Turk. Do you need humans to do something? You need people to look at something. You need people to do things for you, but you just don't have the staff. You don't want to outsource. You just want to get some people to help you with some stuff quickly, pay them, and then get going. All right. Then on the other, so that's you, the requester. On the other hand, there's people that are sitting at home. They've been unemployed. They really want to get some income. Right. They have idle cycles, and they can be put to work. So they go and look for work that people have submitted, and they go do the work. They get paid because the requester got the job done, and then they paid Amazon, and Amazon will pay the workers. So this is a human, literally a human resource, right? So that's that. So workers get paid, they work from home, they can work from anywhere actually, and then requesters will we create these tasks for them to do, and basically they get access to a global on-demand 24/7 workforce, and then they pay when the work is done. So that's kind of like the cloud, except you're leveraging humans to take advantage of that. I think that's kind of interesting too. So some people call it artificial intelligence because it's real. Okay. So that's kind of interesting. So what did we just cover? Kind of wrapping up the talk here. Where does this big data come from? Well, it comes from the fact that we're online everywhere, all the time. We're updating our Facebook status. We're tweeting, or people are, even if you're not. Or you're reading other people's tweets, or whatever, right? So it's because we're online and we're doing computing anytime, anywhere. All right? How do people pick up new skills? Because you know what? In the economic downturn that we had in 2008, 2009, it was horrible, I think. Right? I have a lot of friends that got laid off. I know some people that live in Michigan, but they haven't been able to get a job for 6 years. You got to learn new skills. You got to adapt quickly because the world is moving faster than we can think. So where do you learn new skills? All these online learning systems now that are out there. Right? What will be a critical skill for everybody? Well, everyone's going to have to learn coding, so that's going to be part of the future. Where do all these services live? They're all online. They're in the cloud, so cloud computing is everywhere. All right? What do all these services generate? Lots and lots of data. There's data anytime, anywhere, too. All right? And because we have all that data, we need to analyze it so we can make sense of it. So smart apps and analytics is also going to be part of the future. So again, we come full circle. This is kind of a cycle where we're generating a lot of stuff. Now we have to kind of clean up after ourselves. We made a mess, now we have to clean it up, kind of a thing. Okay? And so, final notes. So desktop software or mobile software will sort of, well, I guess mobile software is already kind of a hybrid. So desktop software will pass into the cloud. All right? The web is old, but it's new. It's the new hotness. All right? What's old is new again. Can I say that? All right? So Google Apps and Office 365 is just the start of putting things online. Why is Google making Chromebooks? Why? Actually, we're not making Chromebooks at all. Samsung, Acer, Dell, HP, Toshiba, those guys are all making Chromebooks. Why? Yeah, I know they're hot in schools because schools use Google Apps because it's cheap, but the reality is more and more stuff is available online, so there's less and less of a need to have a more risky computer, right? You only need a web browser, right? Again, it's not just us. It's us, it's Microsoft, it's Amazon, it's Apple. We're putting everything in the cloud, right? All of us are. So the future has everyone online, anytime, anywhere. Everyone is learning anytime, anywhere. Everyone is programming, hopefully, anytime, anywhere. Even if it's something small, like, going to the grocery store getting milk for your fridge, that it doesn't alert you every time you walk past the milk aisle in the grocery store. All right, data is being generated anytime, anywhere. I don't know how we store this stuff, by the way. Like YouTube. How many hours do you think of video are uploaded to YouTube every minute? How do you guys know that? Oh, shoot. All right. Oh, you read it. You're not supposed to be reading slides. People, what's wrong with you? All right. Yes, 100 hours. You know that's more than 3 days of video are uploaded every minute. And I'm always wondering for myself, when are we going to run out of drive space? How can this possibly be? Because you all know how much video takes up, right? And that's in addition to all the Google Apps documents you have, all the Gmail you have. Where do we have room for this? I guess we store it somewhere because it's cheaper just to store it and not think about it, right? But you got to have smart apps. So we have internal tools that we've developed that help us do this. Our one project is called Dremel, and guess what? That became Google BigQuery because we decided to make everybody else, give everybody else access to it. Because why should we keep it for ourselves when we can share it with everyone? And because you all have a lot of data too. It's not just us. So a lot of our cloud products are actually external versions of tools that we've already built internally for ourselves, just because we have a massive amount of data that we can get a hold of. And I know some people are really paranoid that, oh, Google is watching what I'm searching for and all that stuff, and we have no privacy with Google and stuff. My opinion is, do you think we have the time to care about you? We have so much work, it's beyond belief. I'm not going to go and check what you have on the computer, all right, or what you search for. And besides, security is so paramount for us that you have to have, I can't go to a Google data center and use my badge and swipe in. If I do that, Google security will come find me and my manager and go, what the heck were you doing there? You actually have to have VP approval to get into a data center. Okay, and we have like things that will stop tanks outside of the data center. All right, so you can't exactly, have terrorists driving and blow it up either, right? Unless they have a tank, in which case we have another problem to worry about if a terrorist can get a tank. But it is really secure, and inside a data center, it's even more secure. So for the people that have to destroy the hard drives once they kind of get out of service, you have to have another level of security to get into those secure cages. And we also have, the retina scanner, fingerprint scanner thing. I mean, it has to be total espionage for you to find out what I searched for last week, honestly. It's not worth it for us. You can get fired just by looking at a log that you weren't supposed to. So really, whatever myths there are out there about us looking at your data, it's all done by programs. It's never done by humans. All right? So you can kind of rest assured there. It's just, I have to put some of these urban legends to kind of rest. All right. So last word. Why should people start coding? Look at this. There are 400,000 computer science majors at most in 2020 because it's growing at that level. There's 1.4 million computing jobs out there. All right. There's $500 billion to be made by people. This is a nice slice of a pie that I think everybody should have. Right? There's nothing wrong with learning coding. Being a nerd, being a geek is no longer a negative thing. Right? Especially if celebs endorse coding. Right? Then you know for sure it's not, it's not totally a bad connotation anymore. All right? So thank you everybody for coming. I hope you guys got some vision into what I think the future has kind of developed from, what it's developing into, and maybe in the future all of you guys will create awesome apps that will help enrich and improve people's lives. All right? Thank you.